Lesson 7.3, hyperbolas. So a hyperbola, first off, is like a parabola with a mirroring parabola going the opposite direction. So it kind of looks like just two opposite facing parabolas, but that's what a hyperbola is. Some things to notice about a hyperbola is the focus is located within the hyperbola, just like with a parabola. But since there are two parabolas, there are going to be two foci. There's these two asymptotes that will help us draw, that we'll look at the equation for those. Obviously on your packet you can see they're given down here, but we'll talk about finding those asymptotes, as well as, and the way we'll really do it is you're going to be using the value that's underneath A and the value underneath B. And as I'm looking at this formula, I realize it's missing a minus symbol right there. That should have a minus. So it's this value of x squared over a squared minus this value of y squared over b squared equals 1. That's the equation if it's horizontal. If it's vertical, it's going to have the y first. Now, remember on ellipses, we talked about how the a is larger than the b. What can be deceiving on here is that the a might appear to be smaller than b, but the way to easily fix that is just to think about this b being the negative. If you put this negative with the b, well then this, no matter if this number was 1 and this number was 16, 1 is larger than negative 16. And so it'll work that way, and everything else would work from there. And so that's what I'm going to do. So I know that this will look like the Pythagorean theorem and not like the ellipses was, but if we treat b as being negative, then it'll work just like the same formula from last class. So that's the way I'll do it. So let's get started. First, it says graph this hyperbola given this information. So the first thing I can tell you is that this is going to be a horizontal hyperbola. And I'm just going to write it over here, and I'll show you the final picture in a second. There's no shifts. So we know that the center of this graph will be found here at the origin. It's horizontal because the x is positive while the y piece is negative. So it's going to be horizontal. We need to go left and right 7 units because this refers to a squared. Okay, so we would go left 7 units. 1, 2, 3, 4, 5, 6, and 7. And so this will be a vertex, and then you would go this way. 1, 2, 3, 4, 5, 6, and 7. And go this way 7. That's my other vertex. So there's my vertex, vertices. There's my center of the graph. Now, I would go up and down 9 units. So we're going to treat this as like it's when we take, this is our b squared. And so b we're going to have is plus or minus 9. And you can write that up over here that a was plus or minus 7. So b, we'd go up 9 units. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we'll do the same over here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now here's what's different. On an ellipse, we put the points here for the co-vertices, and we would draw the ellipse like this. It's a little bit different with a hyperbola is we're going to draw the points not on the y-axis, but we're going to draw them right above the vertices. So we'd go here and put a point, here and put a point, here and a point. So really it's the corners, get the points. And so now that we got the corners, these are where our asymptotes come from. This is the rise over run equation. It's ultimately what these are formed by. But I'm going to draw these asymptotes real quick. And so I should have an asymptote here and another one here. Like that. And now I can draw my hyperbola. What I do is I'm going to draw from this vertice going up and towards this asymptote and down and towards this asymptote. And I'll do the same over here. So up and towards that asymptote, down and towards this asymptote. That's what my hyperbola will look like, something along this line. Now, there's also going to be foci, which are going to be inside. And so the way to find the foci is, I know this isn't in agreement with the previous symbol, but if you treat this as negative, you could say that c squared equals a squared minus b squared, the same formula from last class. And so c squared would equal 49 minus a negative 81, which will turn the formula like the other page where it said to add the values. So when I add those, now I get that c squared equals 130. And so c would be plus or minus the square root of 130. And we do not have a square root for that, but I can tell you that it's going to be a little bit more than 11, but yet less than 12, because 11 squared is 121, 12 squared is 144. So it's going to be between 11 and 12. So this was 7 units out, so we'd go 8, 9, 10, and there's 11, 8, 9, 10, 11, and there would be 12, so this would be a foci there. And over here, 8, 9, 10, 11, and there's 12, so the foci would be located there. If you wanted to know the equation of these asymptotes, the y-intercept is the easy part, but to find, because in this one it crosses at the origin. But what you would do for the m in the formula mx plus b, what you would do for your m is you would do the rise over the run. This was our rise. It was plus or minus 9 over the run plus or minus 7. So your equation would be plus or minus the rise portion, which is always with the y, 9 over the run portion, which is with x, which is 7. That, and then since it crossed at the origin, I would just take that part away. Those are my asymptotes there. So I'll include that as part of our answer. Now we can look at their picture, and you can see everything is what I just said. You have the positive 9 over 7x. This is the negative 9 over 7x. You have the foci between 11 and 12. It's 11.4, and those vertices. Now I'll try to do another one. This time I'll go a little bit quicker. And so this will be vertical because the y is positive, and this will be shifted down 4, left 2. And so let's do a quick sketch here. We need to go down 4 units. 1, 2, 3, and 4. Left 2 units. No, I'm sorry. That's right 2 units. It's backwards. Let me change that before we continue on. That needs to be right 2 units because inside is always opposite. All right, so we're down 4, right 2. Now that I have that, how far up and down? This tells me my a squared. So a squared in this part, or a is going to be plus or minus 2 because it's the square root of 4. So I'll go up 2 units and have a vertex. And I would go down 2 units to find my other vertex. And then I will go left and right 3 units because this is my b. So in this problem, b squared is 9, so b equals plus or minus 3. So I'd go left 3 and right 3. So instead of doing it like an ellipse, I'm going to come up here and make them even. Let me try that one again. Even across. So we have points this way. They'll always fill in what I call the corners. And we go 3 this way. Oops, that's not the right spot at all. There we go. And there we go. Now you would draw your asymptotes. Thinner lines here. And so I have this asymptote coming through, and I'll have this asymptote coming through. Now you can tell from here this will be vertical just because my vertices were up and down. So even if you did not get it from here that the y was positive, you can get it from where the location of the vertices are. But this hyperbola will be a vertical hyperbola, like this. The only thing left to find would be our foci. And so to find those foci, remember we use the formula c squared equals a squared minus b squared. And now my c squared, I do not know what that is, but I do know my a squared is 4. And I'm going to subtract a negative 9, which means that c squared is equal to 13, or c will be plus or minus the square root of 13, which is between 3 and 4. So if I went up from the origin, up 4 units, or 3.5 units, we'll just say, 1, 2, 3, and 4 would be all the way up. So it's going to be right underneath. We'll have the foci there. And then here, that was down 2 units, so we need to go down 2 units more. We'd have our other foci there. So there's our two foci. And that would be everything you need to know. If you want to list the asymptotes, it would be y equals plus or minus. Remember, it's rise over run. So we went up and down 2, left and right 3 units. So it would be 2/3 x. And then you would look to see where they would hit the asymptotes. I'm just going to put plus b here. The way you could do so is you would plug in a point that they go through, which they both go through the point 2, 4. And so you plug in 2, 4 for each one to determine if the exact equations. What am I trying to say? If I plug in a y value, I said 2, 4, I'm sorry, 2, -4. So I'll plug in -4 equals, and then I'll do the positive here first. So I'll say 2/3 times 2 for x plus b. I would get my positive equation here. So when I multiply this out, I have -4 equals 4/3 plus b. When I subtract 4/3 over, I need to get a common denominator. This is -4 is the same thing as -12 over 3. And then I would subtract 4 over 3. And that would now equal b. And so I find out that b equals -16 over 3. So my first equation, this one here, would be y equals 2/3 x minus 16 over 3. And then on this equation here, I would do the same thing I just did, except this time, when I plug in -4 for y, I'm going to take -2/3, multiply that times 2, and add that to b. What I'm doing is plugging in a point that each of these lines hit, which is the center here. I multiply it out, and this time, I would have -4 equals -4/3 plus b, and so I add the 4/3 over. So again, it's basically the same math, but I have -12/3 this time plus 4/3 equals b. And so, and I should call this one, we'll call it b2. And over here, we'll call it b1, just so we're not confused. This equation we just found, we would have y equals 2/3, oops, I'm sorry, -2/3. Y equals -2/3 x, and this would be -8/3. And that would be the equation for this asymptote. That should agree with these pictures, or with these values as well. They just wrote theirs as proper fractions. And here's one for you to try.